Okay, this is problem 72 from chapter 4, Giancoli 6th edition. So what we have is a purse, and they give us the mass of this purse, is dropped from a high tower. Okay, so this is, let's put here our tower. And we have this purse here that is dropped. Okay, we have the mass of this purse. The mass is 2 kilograms. So it's dropped. That means that the initial velocity is 0. All right. And they say that after 55 meters, so when it hits the ground here, so this whole height here is 55 meters. So when it hits the ground, it has the velocity where the magnitude is 29 meters per second, and it's pointing down. Okay, very well. The question of the problem is, what is the average force of air resistance? So what is the force of air resistance? If we were to solve this problem as we used to in chapter 2, where there was no air resistance, how would we solve? Well, we would take into account gravity, and we would go for this equation: v squared equals to v naught squared plus 2g delta y. Okay. We have g, we have delta y, and we would find this v, and you would see that this v is larger than 29. This v would be something around 22, 23 meters per second. Okay. So this would be the case if there was no air resistance, the ideal world of Galileo. All right, but what they are saying is no, there is air resistance, and that's why it opposes this motion. That's why we don't reach such big speed at the bottom. We reach just 29. Okay, so how are we going to solve this problem? Not like this. At least the acceleration is not going to be g. Well, how we are going to solve that? We are going to include we are going to look at all the forces that act on this purse. So what are all the forces? We'll have the weight that brings it down, mg. But in addition to the weight, we have this resistance, this force of resistance caused by the air. Okay. Now, the net force is what takes this object down. So we go now for Newton's equation, and let's choose a reference frame. I'm choosing here that positive is down. Okay, so I have that mg is positive. Let me put this equation down here. So I have that mg is positive minus the air resistance, and the net force, the sum of these two, is what causes this object to fall, and this net force is equal to ma. So this is the real acceleration that this object that will cause this fall of this object. Okay, so this object falls according to this acceleration here. Well, what is the question of the problem? They want to know this one. Now, what is the force of air resistance? I know the mass, I know g, but do I know a? I don't know a, but I can find a. How am I going to find a? Well, they gave us information about the initial velocity and the final velocity. Okay? So I can go for this equation here: v squared equals to v naught squared plus 2. And now this is the point. I don't use g, but I use a. Okay, a and delta y. So I have v, I have v naught, I have delta y, so I can find a. Once I find a, I put it here, and then I get this force of resistance.